Assalamu alaikum everybody. Welcome to the Parallel X Academia. I'm Mohammad Sabir Akash with you, and this is the Maths 100 Day Challenge. And today is the day 4. We're gonna discuss about linear systems in 2 and 3 unknowns. In previous class or previous lecture, I discussed about what are called unknowns and what is linear systems. So unknowns are basically the variables, okay? So what is this? So what we're gonna discuss today, linear systems in 2 and 3 unknowns, okay? Unknowns, all right? So what is this? Linear systems in 2 unknowns arise in connection with intersection of lines. For example, we have here a1x plus b1y equals to c1 and a2x plus b2y equals to c2. You all know that this c1 and c2 here are constants, and these a1 and b1, these are also constant, and x and y, these are called the variables, or we can say that these are the unknowns, okay? Now, so in these two equations in which the graphs of the equations are lines in the xy plane, okay, its solution xy of this system corresponds to a point of intersection of the line. So there are 3 possibilities here. Do you get it what I'm saying? So for these 2 equations, for linear systems in 2 or 3 unknowns, so for these 2 equations, there could be 3 possibilities. Number 1 is they could either be parallel, these 2 lines, these 2 equations. So this is a straight line, okay, and this is an equation, so linear equation. This is also a linear equation. So what could be these 2? So what could be the relation between these 2? Either there could be interaction, there could be an intersection between them, or they could be parallel, or these are the 2 things, right? So what are the possibilities that might occur here? These 2 equations, or these 2 lines, or whatever we may call them, okay, these 2 can be parallel. Number 1, they can be parallel. So parallel means, suppose we have, this is a line, so this is a line, okay, and this is also a line. These 2 are parallel. You know what does parallel means, I need not to explain that to you. Then there comes the may intersect only at one point. These 2 lines, and the possibilities is that they could intersect with each other only at one point. So number 2 is could intersect each other one point. And number 3 is, so this can be like this, okay, this is the, you know, this is the xy axis, x, this is the y, and we have x, and this is, suppose that we have here a straight line, and we have this straight line intersects this straight line in this way. So could intersect each other only at one point. And number 3, the third possibility is that these 2 straight line may coincide with one another. How come they coincide with one another? That is, the line, these 2, what does coincide means these 2 line is on the same, they're the same, or you can do these 2 lines are one after another. This is like this. So okay, may coincide. This is straight line. If another straight line, if you draw another straight line over here, okay, above this, then these 2, so there are 3 straight lines, this one, and there are 2 straight lines here. So these 3 straight lines are coinciding with one another. So this is how it is. So for the parallel, if these 3 straight lines are parallel, okay, if these 3 straight lines, that is this, let this straight line be called A and this we call B. If A and B, these two straight lines are parallel, there will be no solution. Okay, there will be no solutions. There shall be no solutions. Where were we? So we are that if these two straight lines A and B, okay, if these two straight lines A and B, if these two are parallel to each other, then there will be no solutions. Okay, these two equations would have no solution. But if they intersect each other only at one point, okay, suppose this is the point where they intersect with each other, so they would have only one solution. How many solutions? One solutions. But if these two straight lines coincide with one another, that means if these two straight lines are one another, okay, then what will be the case? In this case, there will be infinitely many solutions. Consequently, infinitely many solutions. So what is the consequence of it? There will be many solutions. Infinitely many solutions. Okay, now here is another thing, that in general we say that a linear system is consistent. What do we say? A linear system is consistent. So linear system is consistent. This is the general case. When is this consistent? If it has at least one solution. It has at least one solution. So this is a linear system here. There are two equations which is making a linear system. If this two linear system has at least one solution, then we can say it says that at least, okay, not at most. You need to remember that. So at least one solution, then we can say that is consistent. Okay, that linear system is consistent. But if there is no solution, suppose that these two straight lines are, for the first case, these two are parallel, so there is no solutions. So there is no solutions, so this two will be called inconsistent. Okay, linear system inconsistent if it has no solution. Alright,